Hey everyone, my name is Sandeep and today we are going to talk about how we can design a URL shortener. Okay, so what is a URL shortener? So I think you know about a website URL shortener where you can paste your any URL. It can be your website, it can be your any product link, and then it basically give you a short URL. So how basically we can do that? So let's understand in the terms of the what are the functional requirement when we are going to solve this type of problem, what are the non-functional requirement, and how we can basically scale it, what are the problems and challenges we may face when we are building these type of technologies. Okay, so here you can see that the use case is very straightforward. We have a long URL and then we have to convert that URL into a short URL, and once we have the short URL, on click of that short URL we can redirect to the main original URL that we are actually trying to make short. And another thing is we have to give the analytics to the user. So let's suppose if you are the user and you are getting the short URL, you want to see like how many people actually use that short URL. Okay, so that analytics service we also need to think about. Here we talk about the functional requirement. So that is long URL is converted into short URL. We want that short URL will redirect to the original URL, and the last thing is the analytics. So what are the constraints we can think when we are building this URL shortener? The first constraint is like we may have 100 million daily users, and if you are basically writing or creating one short URL, that can be accessed like multiple or million times, right? So the read is always greater than write here, so we just need to think like our system is a read heavy system. And here you can see that whatever the data you are going to make like long to short URL, you need to make it persist. Persistence means that in any case that short URL and that short URL is mapped with which long URL, we never make it destroyed, something like that. Okay. The other is you can think of like every day we may have 2 million users that is using our service to create the short URL. Now, if we talk about the non-functional requirement here, the first thing is the uniqueness. So let's suppose if multiple people is creating the short URL, no two long URL gives the same short URL. Otherwise, that is a problem. Every short URL should be unique. The another is we want the fast redirection. When we click on the short URL, it should be fast, and I want the latency is very low here. We need to think about it. Persistent and handle data loss means in any case that short URL to long URL redirection should be remain persistent. Maybe after 4 years, if someone use that short URL, they are able to redirect to the right location. The system should be high available, low latency, durable, and we want to make sure that the system make sure the uniqueness, that is the main key point of whole system. So whenever we are building some system, from the phrase or the functional requirement, we can come up with the data model. Data model means what are the entities that actually we can use to build a system. Here you can see that we have a original URL, we have a short URL, right? So we need to think how we can store the original URL and then how we can map that original URL to the short URL. The another thing we want is analytics. So somewhere we need to think about when someone click on the short URL, we store the count of click for that short URL. The another is the mapping persistence that I told you about. So this is something we need to think about in terms of DB schema or how our database looks like to store or solve this problem. Here you can see that obviously we need a mapping from original to the unique short URL, and that should be persist, right? And another is the analytics. We need to capture all the read request on that short URL. So we just need to capture all those things. So you can think of two services here. The one service that basically convert that long URL to short URL. The another is the service that basically calculate all the clicks on that. So there are two services for sure. And what are the endpoints we may think here? The first is creation of the URL. So means a post request that actually gives, we actually input the long URL or the original URL, and it basically gives the short URL. The get URL is nothing but a redirection. When someone clicks on the get URL someone clicks on the short URL, we basically redirect the user to the original URL. And again, at that time, we basically need to call an internal service, that analytics service that actually counts the number of clicks on that. And we actually return 302 when we are redirecting from one source to a destination. We give mostly 302 source code. Now how high level, how the system looks like high level. So here you can see that we have one service right now, create URL. We actually passing the long URL, and we use some hashing technique to make this URL short. And some maybe in interview someone may ask you like how you can basically do this hashing, because this is one of the core functionality of the design short URL, how that hashing things or how that whole thing actually works. We will talk about that. And then we basically store in the DB. Now there is a question like which DB we will use. We will use a SQL DB or no SQL DB. But here if you understand like what actually we need, we have millions of users that is actually creating maybe 2 millions of write requests every day. So we actually want our system to be scaled properly. And another thing we want is we want the access or redirection should be very fast. So in that scenario, we just need to think about some database where we can access the URL in big O one time. So if you think some hash map, obviously the NoSQL DB, DynamoDB is one of the best DB. There are some reasons for that. We can easily do sharding, and the system is very serverless and scalable. AWS DynamoDB automatically does this sharding and scalability under the hood, and that is very cool. And Postgres, it is a little bit difficult for us also. So we basically use the DynamoDB to store the short URL to long URL mapping, and how we basically create the unique ID. This is one of the important questions that people may ask. If you see any short URL, the uniqueness, the unique code you can think of is very small. It is not too long, right? Because if it is very too long, then it is difficult for us to store even, and difficult for us to do indexing and all those stuff. So here the first thing is we can use hash function, where we have MD5 algorithm that actually create a hash value of 128 bit, which is very too long. I told you we don't want this, and this is some kind of thing where the scalability can difficult to maintain due to like difficult indexing and all. The another is the UUID, which is also 36 character ID, and that is also a not optimized approach to take the UUID here. The best option in my scenario, you can think of like we have multiple services, because the users, the kind of traffic we are going to have is very high, and in such case we just need to make our system a distributed system. So we may have multiple databases that actually stores these values, short URL to long URL values. So what we will do, we basically take each machine ID, or we can say it is a shard ID, and adding the incremental sequence. So let's suppose there is a machine ID M1, and we are creating some URL S1, which is the first URL, so the value is 1. Now the next short URL come, the value is 2. So the uniqueness we can make is like the machine ID, right, underscore the incremental value. So the machine ID and incremental value, and this uniqueness is always unique. The unique hash we got is very small here, that actually satisfies our requirement. The another important benefit of this thing is, whenever there is a get API call or redirection call, we can simply see, okay, which machine ID or which shard ID this short URL is actually connected to. So in that case, we actually go to that particular machine or shard, and we basically fetch the long URL out of it. So that is also fast in that case, and we are also easily able to maintain the uniqueness here. So this is one of the best option in order to create this. What is the length we want to make for our uniqueness? For that we can we can control the machine ID and the sequence number. So let's suppose if we want that every shard store around 1 lakh URLs, then we can have a rate limiter, right? And that rate limiter is nothing but orchestrator. That orchestrator actually connect with all these shards, and this orchestrator know like which shard have some ideal storage. So whenever there is a request to create a short URL, it basically redirect that request to a particular shard, and that's how we basically can create a URL and store that URL to the shard where we have storage. Okay, and one more thing, if you want to know about what is rate limiting, what that rate limiting orchestrator works, we can create videos on that. You can comment, and maybe I will start with the very basic of system designs too. Okay, so we are done with how we basically store the short URL and how we basically create the unique short URL. Now we need to understand how we can do the redirection. So it is very simple. As I told you, whenever there is a get request on that short URL, we basically see like which machine it belongs to, and then we can basically get the long URL out of it and do the redirection. But here is the case, like this whole process obviously takes some time, because we just need to go to the layer, we just need to see which shard it actually stores in, and then from that shard we need to do the redirection. How we can fast it even more? For that we can use cache, and we basically use the cache. Here you can see that there is a client, and we are using API gateway because we have now two services. The one service is to create the short URL. The another service here is redirection URL. So whenever there is a API request for the redirection, we basically go here and we store everything in the cache. Not everything, we obviously use some cache policy. We may store all the hot URL request, which is whose frequency of using is very high, we can store all that URLs in our cache, and we can use the proper cache policy. There are a lot of cache policy we have, and we can create a video on that too, and we can use a proper cache policy here so that we can update the cache in such a way that we need to do less lookup to our DB. We don't need to go to the DB level, right? So that's how we can make the latency of redirection very low here. Okay, that is also the requirement we have. The another is the analytics service. So analytics service is nothing but a counter. Whenever someone clicks on the short URL, we basically increase that counter by 1, right? But if you think like you are going to store this whole thing, like whenever someone click on the short URL, you are calling that counter increment to the DB, then there is a lot of DB load, because I told you there are multiple reads as compared to the writes. So maybe there can be, if there are 100 million reads for like every day, then maybe for a request it can be 1 million in the high peak traffic value time. So in that case, what we can do, we can basically use the in-memory, and in memory we can store that counter, and we will schedule some cron, or we will schedule periodic job that basically update that in-memory counter to the DB, so that for DB we have a very less calls, and everything counter value is every time increased inside the in-memory, and that's how we can make our DB easy, like so that there are no such high level of direct calls to the DB, write calls, and we periodically we can simply update that count value. So this is what we can do here to optimize the analytics service, and that's how we are able to design the whole URL shortener. And how we can handle the traffic, that is already we talk about, like how we can use sharding. And by sharding means we basically create multiple DBs. Each DB has some capacity to store the URLs, and how basically the redirect works, that is the machine ID or shard ID that actually tells our service like which shard we need to call to get the data from. So that's it for this video, and I hope it solves most of the problems. Like we saw like how we can scale it, we saw how we can make our URL unique. We also talk about that how we can make our system persistent, and how we can basically use the cache here to maintain the low latency system here. And I hope this video helps you out in learning these concepts. Thank you. Bye bye.